Hi, Mish, welcome.
Welcome, everybody, to this February 2025 OpenZFS leadership meeting. Thanks, everyone, for coming. This is our early edition, so I think we get slightly different people than usual. But I guess the first topic on our agenda actually is Igor wanted to talk about some design work he's doing for a zpool or ZFS fsck command, specifically looking at the logical consistency of the file system in that, every file is actually linked from a directory somewhere, and there aren't any orphan files and so on. This mostly comes from some work recoveries and so on that we've done where we see if a directory entry, or more particularly, like if a dnode gets damaged, then we can't reference any of the 32 objects that are in that dnode. And if one of those happens to be a directory, then you can end up with all the files under that being perfectly good as far as the scrub is concerned and so on, but not accessible anywhere. And trying to just identify how many files are orphaned and which ones those might be, so that we might possibly reconnect them or something. I think that at the moment, the main goal is just to assess and determine, is everything okay or not necessarily to fix anything. But yeah, Igor, do you want to talk a bit about what you had in mind?
Yeah, hello everyone. Nice to meet you all. So it's expected to be structured like another scan type, like we have already, like scrub, for example. So it's going to play the same rules that only one of them can be running at the same time. And it's expected to be a usual depth first search through the dataset metadata. So we are going to iterate over all datasets, but work only in single dataset at the same time. And there are optional ideas to work with the bitmap or with something bigger, like 8 times bigger, to count all the links of the files. So it could save space on the production server. So this is a discussable option. So bitmaps means to mark that file was visited, so it's linked from something, from some directory. And if you want to check all the links, we need to count all the visit times. So maybe it could be an option to implement it both ways, or maybe just go one way, because of it depends very on a production case when we may have a lot of objects within a dataset, and it could be a huge map to store. And another idea is not to store the whole map, but split it onto chunks, like page size, power of page size chunks, and have another metadata which refers to such submaps. And when the whole submap is like covered, like we visited all the files, so we counted all the links we wanted to count, we could just free the space and mark it like this specific range is covered, the range of objects within a data set. Of course, we cannot expect that all such submaps are going to be easily collapsible through the scanning process, but it's a discussable idea to have and maybe implement from the scratch to have some less memory consumption during the scan of space maps, because of the design of the ZFS actually provides some expectations to have something allocated near to each other. I mean, the objects like directory and the files, they could be quite close to each other for some usual use cases. Also, the idea is to track errors found the same way we do it with Scrub, for example. So we have error log, and we have already option like head error log, which allows to store it more efficient way and also to add transaction group information per error. So we could store it like this. Maybe we could use a specific type. As I remember, it's based on indirection blocks. So on the level of the indirection, as I remember, it's used for specific objects to refer to, like
Yeah, I think it's
-1,
a
-2, -3.
ZFS
Yeah.
bookmark. And so Scott,
Yeah,
yeah.
bookmark. Yeah, design in such way. Maybe we could use the same way, the same trick to differentiate usual scrap issues because of they are treated by other programs, how to output it, how to present it to an operator, and differentiate it from these usual errors, these new errors, we could call it another way, and use -4, something like that to differentiate them from other cases, just to use the same error log. And if head error log is presented, we could use also the transaction group, not like the burst time of a block, how it's used on the scrap side, but we could use it just to mark the transaction within which we found this issue with orphan file or directory which is not linked. So it expected to have n links, and we found less than n links or 0 links. So this is how we could track it. It of course needs to improve the tools, the CLI tools, to treat it respectively and output it respectively. That it's not about corruption; it's about unlinked files. So this is the basic set of ideas regarding fsck. Another extra idea. Sorry.
But Alexander had something.
Well, yeah, I just like to comment that first, I'm a bit surprised that you care specifically about this kind of corruption. We have so many potential things that can be corrupted other than individual denote blocks or references to something. So, well, yeah, sure, original fsck was looking for lost files, but it was implemented in times of non-transactional file systems where I guess it could happen more easily. I don't know how much it applies to ZFS. Honestly, I never had problems with that. Maybe somebody did, but
yeah,
whatever.
So in the case we saw, it was basically one of the directories kind of close to the root of the file system whose dnode was irreparably damaged. And so ZFS identifies this one dnode in the zpool status-v and says, that one thing is broken. But it meant there were 17 million files that you couldn't reach anymore because that one directory was missing or unreadable.
Oh, yeah.
And so being able to show which files aren't reachable or which ones are could be reconnected if we just make the right links and so on, I think would be useful here. But go ahead.
Oh, yeah. But my first, not objection, but a comment to consider would be that in scrap context, we are not technically allowed to make changes because we cannot have any file system level logs. So
right.
we cannot change anything.
We're not proposing to fix any missing files, just identify them.
I guess we already have a search for lost blocks in ZDB. Maybe we could add search for lost denodes in ZDB too.
Possibly.
Sure,
at one point we were looking at possibly extending this fsck to also do something similar to ZDB does, of looking for any space that's not in the free list but not referenced by any block pointer, and vice versa. But that, of course, involves looking at every single block pointer, which is a lot more work than just looking at each object like we'd be doing for this, where you only have to look at each
sure,
object instead of every record of an object.
Yeah, well, just okay, we can search, we can find, then what shall we do about it? If we can do something, I was thinking potentially maybe we could expose lost things in some hidden read-only directory in .zfs or somehow else to make it sure it doesn't collide too badly with VFS locking.
Mm-hmm.
Can we recover lost blocks? That's probably bigger question. Can we redo all the space map on a flight from real data? Maybe that would be too much.
That one might be interesting in one of the later items on the discussion list.
Okay.
Yeah, it might happen to be like dot lost and found, something like that.
Well, in particular, if we made it its own error list, then maybe the dot lost and found would basically read that error list and provide you a way to, you know, synthesize new VFS entries for every object that's lost or that's on those error lists. And that might be a way to do it where, as I was saying, like the only thing we're writing during the fsck is the error list, and then the hidden .zfs directory under lost or whatever would then pull up that error list to, you know, provide you access to all those files that are disconnected. And that might be a way to do it without, like Alexander was saying, avoiding any of the complexity of trying to make any changes to the VFS while doing the scan phase.
It may still has some races if things are modified while we're scanning. We first found that some denote was not used, but millisecond later it was added to a directory. And in sync context, in scrub context, we have no logs to properly access that.
Yeah, we'll have to think about that and see what we can do there. In general, the scrub's looking at, well, it's not always in transaction group order, is it? Yeah, I have to see. Okay.
By the way, regarding this fsck, just thinking out loud, if we imagine that if it exists, we can reason that its existence actually happens because we have some issues in the code, right? Presumably, which leads ZFS state to such corruptions. Then maybe such fsck could be also used for ZFS test suite. If we imagine that we run a test, it leads to some state of ZFS on disk or in core at the same time. And as a final step, we could run this fsck just to see that the state doesn't have such issues. So we don't have orphans or something like that. Just thinking out loud, maybe if it flags that it happens like this, we get some unlinked files and directories, maybe it will help us to locate the issue, to see, this test fails because of it finalizes its work and leaves the file system with such state. Maybe something in the logic used here, we have such issue. Just thinking out loud, it's not a proposal, but maybe it could be used like this.
I don't know if I've ever seen orphan files that were actually caused by a bug in ZFS rather than damage at a more like hardware level. But
I also have a feeling, no, it kind of makes sense for me. I would just say that I have a feeling we already test for block leaks, maybe in the test or I forgot where. But
there's something, yeah, the ZDB has something for block leaks and some of the tests use it for something. I think it does get run on a couple of the test suites.
I think when the test fails, it runs ZDB and ZDB can report what's wrong with the pool, like block leaks.
Okay, the next item on our list was we wanted to revisit the discussion on Slack compression, mostly so that we can look at getting the on-disk changes for that kind of solidified so that we can go from there. I don't know if anybody's had time to look at this anytime recently. But to recap, this is the idea that in cases where compress equals off, because in this case, the customer is storing encrypted data, and so they don't, they're not going to benefit from compression. So the data was encrypted at the application layer before written to ZFS. But when using a large record size, like record size equals 16 megs, then if you have a file that's 20 megabytes, then you end up with two 16 megabyte records, as opposed to with just basic compression on, it would do a 16 meg and then a 4, and it would compress off the zero padding at the end. So Slack compression, rather than actually doing any compression, is just doing a reverse search on the last block to find runs of all zeros and kind of set the physical size of that block to the amount of physical data in it that isn't the zeros on the end. So getting some of the benefit of compression without actually having to run every block you write through the compression algorithm. Saving all the mem copies and so on that are involved in the normal compression routine.
Yeah, I haven't looked on it lately. I see the PR market drafts. I need to refresh where it ended up, in what state.
Yeah, I think we refreshed it in January, but do need to look at it again. But mostly there's wanted to get any feedback on the general concept, and especially the on-disk format changes, so that we can get those solidified while we hash out the rest of the actual implementation details. Just any of the stuff that's harder to change after the fact, if we can get agreement on that, that'd be good. So
will it be just a block with shorter p size than l size, or?
Generally, I think yes. But I think for that to work correctly, we do have to set the compressed flag.
So it'll be some kind of compressed, but without actual compression algorithm. Or it can be maybe represented by some compression algorithm.
Yeah, a null or whatever. Yeah.
Yeah. Well, if it's some additional compression algorithms, generally I don't think I have objection, but I need to take a look on actual implementation.
Yep. Thank you. Next up was yours, Alexander. You got the unified allocation throttle. This looks like a really nice improvement.
Yeah, it hangs there for 3 weeks, and I'd like to again invite everybody to take a look. It was bugging me for years that we have practically two different VDF balance algorithm, one based on performance, which is called allocation throttling, was added later, and originally existing in ZFS quota-based allocation, which just assigned each disk some amount of data to write before switching to the next top-level VDF. And unfortunately, introduction of allocation throttling was implemented in context of IOs, not in context of bytes. So those two algorithms was very difficult, if impossible, to integrate. That's why I rewritten allocation throttling algorithm from requests to bytes. It actually went slightly simpler in context of gangs. Since I don't need to account each chunk of writes that was split into gangs. Just need to account for the gang header, and that's it. And that's simplified code there. But also it allows aggregation of integration of those two algorithms. So it should now be able to handle both performance and space distribution between VDFs. One downside I can call myself is that to not overcomplicate allocation code on each rotor turn, each VDF should allocate at least one block. And if that block is big, even almost full VDF will still try to allocate something until it fails. So that way, this algorithm is slightly more restricted than original one. But I find on my tests, I think even if I create some imbalance, unless imbalance is too huge, it will still, with time, will try to adjust VDF usage. But again, worst that can happen, some VDF will get 100% full and will just skip allocations completely. So I don't think it should be terrible. But that's only one issue with this implementation I can think of. But I'd be happy if other,
still respect the, was it Metaslab group no alloc threshold, where, you know, once it's down to like the last couple percent of space, it will avoid allocating?
I don't think I removed that. I just don't.
I think the
trying
default
to
is
recall
0 anyway, so it unless it's been tuned, it doesn't actually apply. But maybe
No,
it's
yeah,
a test
I
we can create for it.
I haven't removed that parameter, but I think it works. Maybe it works through the removal of. I think it removes allocatable flag from VDEF or something like that.
Yeah, I think it passivates or something. The Metaslab. Yeah.
Yeah, and I think those should be obeyed.
Yeah.
Same as before. I haven't removed it.
But yeah, like looking at your results and just the tests you did and so on, I think it makes good sense there, especially balancing towards filling the VDEVs evenly when the system's not under a lot of performance load. But then when, you know, the application is asking for all the performance you can have to just use up every disk. I think that's a really nice trade-off that will, you know, get towards evenly filling the VDEVs when we can, but not at the cost of performance when we need the performance. So it seems like a really nice trade-off.
I can, like, only self-criticizing. I can think of, like, can say that it's prioritizing a write performance over reads. Potentially, we could write some more to empty VDEF to make even if we don't need write performance, so the read at the end would be faster. But I guess that's just it doesn't have obvious answer.
Yeah. And I think what you have is the best trade-off of all the options. Because yeah, like we could purposely try to spread the writes out across as many devices as possible, right, until everything's, you know, 99% full, because that'll give us the most read performance. But that just means all the writes we do after will have really, really bad read performance, instead of this closer to a mix that you're doing of the two. Seems like will give you the best overall over time. And, you know, if you really want it to be as performant as possible, then don't have your VDEVs be so unbalanced.
Yeah. So after your last comment, I added the tunable to allow to control of how exactly we should balance performance. Either don't care about performance or always prefer write performance, or do it based on whether we're busy or not. So if somebody wants to make faster VDEF always write faster, it's possible now.
Yeah, and I think with some other stuff we're looking at, the always go towards more evenly balanced could be useful for some people as well. Like if people are knowing they're going to have this mismatched VDEV and are willing to take the performance penalty for it in order to, you know, balance out their writes, then they can tune that way. So I think that's a good compromise.
Thank you. Please, anybody take a look on the code. I'd be happy to merge it. Science, it's also a bit conflicts with Paul's later work on Genk and other things. So I think it would make sense to merge it first and then work on Genk after Science. As I've told, it simplifies Genk accounting and queue management around it. So I think it would be easier to do it that way.
Yeah, I will. We can get some time test on looking at that, especially since it's related to the gang stuff now.
Okay, I'd like to bring one more topic next on the list. There is already a PR for like 6 months and unchanged for few to implement default user quota and default group quota. As I commented there, I don't like how it's implemented because it introduced some weird ZAP to store only 2 entries, which makes no sense to me. That's why I'd like to bring a question in case somebody has quick thoughts to argue. I tried to look, and I don't see that UID, GUID, or project ID of -1 would have or could be used by the OS. Team ZFS already, yeah.
Like usually the way that's actually implemented, like -1 is the nobody user that's actually like 65535, right?
No, with this -1, I mean ULL, so it will be 64-bit. It will be many zeros,
yeah,
OFFs, whatever. No, first argument, obviously, since both FBD and Linux at very least have 32-bit user and group IDs, that -1 should be practically unreachable. On Solaris, there is a concept of domains and FUIDs to handle those domains that are stored in upper 32 bits, but since they're allocated sequentially, having 4 billion domains, it's also unlikely. I don't even see in the code any checks for overflow. So I guess it's impossible to get both domain of -1 and within domain UID of -1 too, which it seems like at least both FreeBSD and Linux VFS layers don't allow UID of -1 even within 32 bits. They consider it as invalid or no value or whatever. So if nobody can think of anything else, we're probably going to write alternative version of default user group and maybe project quota patch that uses -1 key to store default value in a ZAP of quotas. I think it should be much cleaner at the end rather than introducing.
Yeah, because I think the current version of the patch does it as a dataset property.
No, it introduces into dataset, it stores object ID of ZAP. In that ZAP, it stores only practically two value of user quota and group quota. And it's just overkill, over-engineering for no reason.
Those two as just properties on the dataset would be less bad, but it makes sense, as you're saying, to put it in the ZAP with all the other quotas, since, you know, if you have to read the default and then set somebody else's quota or whatever, you're going to need the quota table anyway, right? Whereas you might not, the ZAP of dataset properties might not be hot. Whereas if you're dealing with quotas, the quota ZAP should already be warm. So yeah, I think that makes sense. I think that also works better for, I know at the developer summit back in October, the people from AWS were also working on accidentally rewrote a version of this at the hackathon. And I think this works better for their needs as well, in that I think they're exposing all the quotas as something under the .zfs directory, because they provide access to their ZFS storage only over NFS. So you can't run any of the ZFS commands directly, but you can interface with them via VFS stuff. And so making it, you know, just this magic username in the quota list seems like that would work better for them too. So I think that is the best way forward.
Yeah, there are optional RPCs for NFS to manage quota remotely. I'm not sure whether it would allow to manage the quota of -1 remotely, or actually I don't remember whether it uses UIDs or names. But if it allows names, it should not be a problem. If it uses UIDs and GUIDs, it may be difficult to,
invalid value, yeah. But I think they're doing it all with the .zfs stuff that they invented. I'd have to go and look at their presentation again. I don't remember all the details.
Was there any drafts that could be useful, or
I think they only worked on it for the afternoon at the hackathon, so I don't think they got that far. But yeah, I think storing it in the quota list makes most sense there. The next one that we had was we've updated our old pull request for exposing zpool status JSON via the kstat. I know, Tony, you had some thoughts on this. So the big thing that we did was we synchronized it with the JSON generator that IX added for user space. So the kernel now uses the same stuff instead of its own. And you did a bunch of work to line it up so the output looks the same. But the big difference obviously is the user space command needs the SPA namespace lock in order to turn the pool name you put on the command line into a link to the pointer to the SPA key, whereas the kstat already has that, and the kstat is basically controlled by the creation and destruction of the kstat are under the SPA namespace lock when you import or export the pool. So there's no chance of ever trying to dereference the SPA key that's been freed or something like that. But our pull request does add the option tunable to allow it if it fails to try lock the pool config lock when it's trying to go over all the VDEVs because something is jammed up, then it can just proceed without the lock since it's just reading. And unless you actually are detaching or removing a VDEV as you're generating the JSON, it shouldn't cause a problem. But this way, if a pool's suspended or something while holding that lock, you'll still be able to get status of the pool, unlike with the command line tools.
I think list array list of children VDEVs is stored as array in VDEV. So I think even addition of VDEV may be a problem. So I'm not sure I'm comfortable with skipping that lock.
Well, this is so we try lock it first. So if we can get it, we take it. It's just if we try and wait and try and still don't get it, then we're assuming that no amount of waiting would ever acquire this lock in particular, such as something it took that lock and then the pool suspended. And so the lock isn't going to be freed until somebody gets zpool clear or the system is rebooted entirely.
Usually people complained about namespace lock, and namespace lock should now be punched during number of operations, and we could continue that. I'm not sure how much is a config lock is a problem, but yeah, maybe it is.
Yes, I like that the updated PR added the module parameter to basically take the safeties off, because I think that can be really useful if you have a pool that's locked up and you still want to see the status. What I was saying in the PR was, if we're going to go that route, why not you disable the safeties, but then allow zpool status to work without safeties? Then you get that nice familiar zpool status output. You get the formatting options in zpool status. You don't have to have the JSON output. You can have the normal zpool status output that everyone's familiar with, all the syntax highlighting. And it's a lot less code. So that's where I was going with it.
Well, I think the SPA namespace lock is still a problem with the user space, though.
No, I posted a prototype that I kind of whipped up that just skips the SPA namespace lock, and it seemed to work for me. I didn't exhaustively test it, but it worked for me.
I suppose, unless somebody's doing an import and an export at the time.
Yeah, if you're doing an import or an export, you're going to panic, unless, well, depending on the timing, but you could have that problem either way.
I think right now we have a flag, something like busy, dirty, whatever. So you first take namespace lock, you put that flag, you drop namespace lock. After that, anybody else who is trying to look for that pool, it will see that pool is marked as dirty, busy, whatever. So it
right. I think that was part of the parallel import and export changes.
Yep. So that's why I say it should be some less problems than before. Maybe it could be further improved, but I think it would be a better way. No, it has to be done anyway. It just we worked on that kstat.json implementation too for some reason in the previous iteration of that patch, but we ended up abandoning it since it can never be the same JSON output as generated by user space. It will be different, it will be code duplication. And at
Yeah,
the
so
end,
with Igor's version, I think we got rid of all the code duplication that is possible to get rid of. It is much less beefy than, obviously our initial version was before there was the command line JSON at all, but I think now it's in much better shape. And I think Igor even commonized a bunch of the literal strings and so on to try to match a bit more of the output and to avoid any duplication there.
Well, yeah, I haven't looked on the code yet. Maybe I will.
Yeah,
Yeah,
it was accounted.
Hmm.
This question about code duplication was used like a key point left from the previous PRs. So this is what we tried to address.
Yeah, I still think it's useful. I agree with Tony that, maybe we can get the command line one to be more useful too. But it still seems that there will be cases where, already having the spotty from the case stat will be more useful. Okay, the next item actually kind of comes back to one of the points Alexander raised when we were talking about fsck, which was the possibility of maybe regenerating the space maps on a pool when they somehow are wrong. So on this one, we have a customer that has a bunch of pools that when they go to import, they find that they're getting panics that there's a chunk of the when they're trying to add an allocation or a free from the space map log to the range tree as it's loading those up when it's first importing the pool, that they're getting an allocation for something that's already allocated or free for something that was already freed, and that causes a panic. We've seen this in the wild a couple of times over the years. And in general, you can set ZFS_recover equals 1 and import, and it gets past that little hiccup and the pool seems fine afterwards. But we have a customer that's seeing this more widely now. And so because ZFS recover is kind of a big hammer for that, we created a separate tunable that just applies to specifically make these couple of asserts around the Metaslab range trees, not panic the system, and to default them to whatever would be the safest thing for that particular operation. So if it's a free, we don't actually free the space, we'll leak it. And if it's an allocation that overlaps, then we will at least allocate, mark the non-overlap part as allocated as well, so that that space can't get reused. Igor, you want to maybe, is there anything else to share on that?
Yeah, so first of all, existing ZFS recover doesn't cover all the cases related to the range tree adding or removal. So we needed to extend actually the logic, the recover logic. And as Alan mentioned it, basic idea of the existing ZFS recover behavior is just to ignore an unexpected case. But for some cases, we see that the safest path is not just to ignore, but actually add or remove the missing or overlapping or not overlapping chunks. Because otherwise we don't know the source of this unexpected additions or removals of range tree, and we are trying to think about the worst case scenario. And if something allocated it before or tries to allocate it right now, we try to do such allocation. So we use a potential space leak as a trade-off instead of actually trying to keep something as free and it can be overridden in the future, right? So with as a trade-off we move forward with.
Yeah, the first thing I wanted to ask is, anybody else seen these panics about trying to add an entry to a range tree that was already there during import in the wild. I think over the last 10 years, I've seen it 5 or 6 times in total. Never very frequently. I think the first time I saw it was somebody was trying to do something with PowerPC, so I just blamed PowerPC. But
generally, panics of those addition of already added segment, they happen quite regularly. Most often they happen on some desktop grade users, hardware users, where I traditionally tend to blame it to non-ACC memory. But honestly, I can never be completely calm about it, not worrying science. I also worry that we are maybe doing something wrong somewhere. But science, it normally happens somewhere too late. For example, when somebody destroys a data set, and that destroys snapshot already have its dirty lists or live list or whatever they called.
Yep.
And by the time we have no idea what was those pointers, we try to freeze them. They're already free. It crashes the system, reboots, probably crashes again until somebody sets the magic ZFS recovery flag. It does nothing and continues. So as a kind of better version of ZFS recovery, if it's another flag or somehow else not default behavior or at least very visible behavior, I tend to think it's an improvement. But my biggest worry is just not hide something.
Where's this coming from? Yeah.
Where's this coming from? Yeah. If we have any chance to get closer to origins of what actually goes on, we should use it. Otherwise, it will follow us forever.
Yep.
That's scary.
Yeah, so I think this one it's a new tunable off by default, and when set, like ZFS recover, except for instead of just continuing, it actually, for the free, it will not free anything, and for the allocation, it will at least mark the non-overlap part that isn't already marked as allocated. So like if it's an allocation that covers a partial, because that'll be safer, and also log a bunch of things, and maybe it'd be great if viewers have ideas of anything else that might make sense to log there, to be able to try to go back and figure out when this does happen, where this might be coming from. And I think to some degree it'll be a bit easier to get cooperation from people if we can use this to let their pool get imported and then look at what those ranges and block pointers were supposed to be pointing at or whatever. Versus, if we want to write, if we want them to run a bunch of ZDB stuff and their pool won't import and we won't help them until after they do it for us, then they tend to not cooperate as much.
Yeah, sure. From a user perspective, it would be much better if it recovered faster and automatically. But I guess same as with all the panics, there is a chance that if it panics, then maybe after reboot, we'll pass it. Science, it was like in memory corruptions that happened just now. Right. But as in the case
so this would work the same as zpool recover, where it's off by default. They'll still get the panic, and then we'll just be able to give them a less big hammer that's safer to get past that during import.
I haven't looked what ZFS recover does in that case, but could it be improved also to behave in a safer way?
Probably. I think right now it's just any panic call is just, we do like panic _ recoverable or something, and it just means it skips the panic and continues through the code. But yeah, to your
I just mean
maybe,
specifically to improve the case after the panic. What does it do if in case of error, if not panic?
So here we try to actually, if we didn't panic, we try to add or remove, it depends on the case, the overlapping or non-overlapping chunk. So we just go the path to leak space instead of just ignoring a segment, adding or removing. So actually this extra parameter, ZFS recover MS, it's just a subset of ZFS recover. So if we enable ZFS recover, it includes the same logic. ZFS requirement
so
is
this-
just a subset related just to MetaSlab loading situation.
Ah.
Because of
Also-
production, the specific production cases, they happen at they actually need it not only during import, they need it for for running the pool, because of it could be imported without issues, but some corrupted, let's call it so, for example, MetaSlab can be loaded maybe tomorrow or maybe in 1 hour, and that's why they need it like enable it always. But the ZFS recovery is not expected to be used like 24/7, right? So we just minimize the mitigation just down to the MetaSlab loading. So other issues covered by the ZFS recovery are not impacted, and they're still going to panic and do whatever they do. So it's not related probably issues, so they can be flagged as usual. But only MetaSlab loading situation could be mitigated if operator needs it and keep it, turn it on.
Oh, yeah, so that sounds good. If I hear you correctly, that the FS recovery will help the same leak logic as you
Yes.
described.
Yeah.
So it'll improve that and give you the option to enable just those mitigations instead of all of them, so the rest of the things stay as a panic.
Sounds good.
Great. And then, Alexander, you have your pull requests about better filling metaslabs. I think we talked about that just a few minutes ago before the call started.
It's a pretty small change textually, but maybe slightly bigger organizationally. I found that when we are starting new pool and starting filling it, we have a logic to switch metaslabs as soon as biggest sequential chunks reduces by 4 times. But actually, since all metaslabs are power of 2, we switch metaslabs as soon as we get like 1 byte below half. So if you fill the pool by 50% of capacity, you effectively have all metaslabs fill it to 50%. And after that starts logic of 4 periods. So it will be first everybody to the half, then it will be everybody to 7/8 and so on. But I don't think it's very, no, I have no argument why would we need to fill all metaslabs to a half. I think it should be better for data locality if we fill each metaslab to full, if it's sequential and if it's not fragmented. That's what I added in a code just to skip metaslab switching in that case. I'm not sure I'm very strong in that area of code. Not sure they use all the primitives correctly, but I think so, and it seems like it does work on my tests. So I'd like to second set of eyes to comment on that. Also, it depends on other fix I pushed earlier when we accounted fragmentation incorrectly, so that if we have some metaslabs with only 4 kilobytes of space, we consider that it's been 50% fragmented as if it would be like every second 4K of been free, which is obviously not the same. So if you apply this proposed improvement without the previous one, you could pretty quickly get pool highly fragmented. But since the previous one is merged, is already committed, and we could merge it down to older versions, I don't think it should be a big of a problem, unless somebody just try to downgrade. But again, fragmentation in that case is mostly a cosmetic issue.
Paul, did you have something to add?
I was just going to say that I took a look at the patch and it looks good to me.
Oh, thank you.
Great. Yeah, we saw this when we were looking at some of the other stuff you saw recently with the changing the fragmentation logic and so on, because when we're allocating large blocks, like 16 meg records on a RAID Z3 take 22 megabytes. And yeah, one of the things we were seeing is that once the metaslab was half full, we stopped using it, and we didn't understand why. If it still had lots of contiguous space that could handle more 22 megabyte allocations, it's like, why are we switching? Stop switching.
Yeah, that should help. At least it should help for empty pool. Once pool has been filled and then partially freed, it may use the previous of like 1/4 logic or like 2 steps, whatever we call it. I think after that point, it makes sense. Related to fragmentation, I haven't mentioned it on the list, but we are right now, Amir is preparing list of patches to propose for 2.3.1. Paul or anybody, do you have objections to merge the new scale of fragmentation into 2.3.1?
No, that makes sense to me.
Well, yeah, it's just a visible change for a user, so I don't think it's a regression or anything. It's just theoretical pool violations. That's why I'm asking second time.
Yeah, I mean, there's definitely, it's possible some user will see the change and be confused, but I think as long as there's something in the change log or whatever, and you know, I think it'll be fine.
Okay, thank you.
And then, Paul, you have your pull request to make gang block redundancy respect the redundant metadata property.
Yes, yeah. So Alexander's taking a look at that one. But basically the idea is that we have this redundant metadata setting in ZFS, and specific file systems can set this to reduce the number of copies of different metadata that they store. Right now, gang blocks ignore that completely. The rule for gang blocks right now is just like if there would be 1 copy of a gang block header, there is instead 2 copies. Regardless of what level it's at or anything else like that. So the change just teaches the gang block code to respect the redundant metadata setting. It's built on top of the dynamic gang block header changes, just because I was doing a lot of work in the gang code in sequence, and it was convenient to sort of build them all in order. So that PR is up. I know Alexander's already taken a look at it, but if anybody else wants to take a look at it, they should feel free, and I welcome any feedback they might have.
Well, yeah, I looked on that, but as I written there, I like the change itself, but I'm not so much comfortable with putting it on top of other changes, which are huge. It's a separate PR about introduction of bigger gang headers. I think same as I told in other PRs, I think we could first try to improve gang as they are without breaking compatibility, and then if after that all not enough, after that, then generally I would postpone breaking on disk format till the last moment until it's really necessary. So,
I mean, there's a feature flag that people can choose to enable or not enable for the dynamic gang headers if they don't want the read-only incompatibility.
no, that's true, but most people, and me including, just run zpool upgrade without picking separate options. And after that, it's only a question of luck and pool usage level to see how soon it will get activated because the first block is written. So, like, I'm not saying that that feature have no place to exist. I think it's just that again copies or the change in other one flexible allocation, they could exist without that feature. So I don't think if it can be refactored, it's the other way around to learn them first. I think it would be beneficial to learn them first, and then after that we could think about bigger gang blocks.
I mean, I've spent a while thinking about it. I don't believe there is a way to do larger gang headers without a read incompatible format change. I think it is impossible.
No, I'm not saying that's
I think you're
possible.
saying, is it possible to do the redundant metadata patch first?
Sure, we could do that one first, but if we want to land them all, why should I do extra work to reorder them when like they already exist, right?
No, the other patch, it's just, to me, it's more like experimental hack at this point. It should probably mark it as draft yet. Science, in the way it is, it can't be landed. Sure, it's interesting direction.
Why can't it be landed?
No, for example, looking at what exactly it does about ZIO converting GAN header write, GAN header rewrite into normal write. It's just such a mess for Zio modifying individual parameters. I commented in there, and there were a few others. A few other comments if you had chance to look. I think it was a couple days ago.
Maybe it was updated since I last looked at it.
Yeah, I commented yesterday or 2 days ago. I forgot
Okay.
recently.
Yeah, I looked at it yesterday, but the updates hadn't come in yet. I'll take a look at those comments.
No, and generally we are so close to 2.3.0 release. So would we introduce new feature now? It could create potential problems with downstream, specifically FreeBSD. I don't remember whether next stable branch for FreeBSD is planned, but would we introduce new feature now? It would definitely be a question whether FreeBSD should maintain master for now and then get new feature, which cannot, which is unclear what to do about stable release. Science feature is not in 2.3.0. Or not update master, just dragging it to the point of branching. So that's another reason why I would prefer new feature to be postponed later. Like I'm not objecting about bigger GAN headers. It kind of would make sense. It's just I would like to be less dirty, like not requiring compatibility, but yeah, I understand its usefulness. But as I commented before, its real usefulness appear only when we really need those additional pointers which require flexible allocation. I don't want we just split every block we cannot allocate into 512 byte or 4K chunks,
Right.
just because we can.
Yeah, and I mean the flexible allocation code is in there now.
Yeah, it's just if we could factor it out to land it first sense, it can perfectly work with existing 3-pointer GAN headers, even improving that potentially. Science, right now we split pointers hard into 3 chunks, but we could be more flexible and more adapting to what actually allocator can do. Maybe in some cases we could fit into 3 pointers that we can't do now, or now we have to do it several layers of gangs. Instead, we could fit into one more efficiently.
Yeah, I mean, I'll take a look and see if I have time to refactor the changes. Yeah,
Thank you.
I'll see
Appreciate
how much
it.
that'll
So
be.
you're saying so Alexander, you're saying, can we get the dynamic allocation stuff without the 4K stuff?
Yeah.
For now? Okay.
Yeah, and the redundant gang header stuff
Yeah.
without the dynamic stuff.
Well, if we do, yeah, I see what you're saying. Yep. And then I think we have about 90 seconds left. Do you want to talk briefly about the dedupe log syncing improvements?
The dedupe log pacing stuff?
Yep.
Oh yeah, so there are some changes. So right now, when you're syncing the dedupe log, we do it over multiple sync passes in a given TXG. This was an attempt to sort of try to pace it out a little bit and not dump a bunch of writes in any given pass, but this removes a bunch of the benefit of the dedupe log, which was to try to coalesce all these writes together so that you have as few updates to indirect blocks as possible. By spreading it out over multiple sync passes, now you're updating the same indirect blocks multiple times in a given TXG. So the changes are to move it. So first, it moves it all into the single sync pass so that all of the updates happen at once. And then the algorithm by which we decide how many updates to actually sync out has been changed. It's no longer controlled by a bunch of tunables that affect like always update exactly this many, try to spend, this much time, like those parameters. And instead it's based on a like turn over the log in this many TXGs. which will sort of naturally result in the log balancing out at, you know, the product of that number and the ingest rate. And so the log will sort of always stay at a reasonable size. And the flow rate will vary a little more organically. And it's a little bit easier to tune that way, and the parameters are a little simpler. And it doesn't have quite as many artificial dependencies on random numbers that the user has to understand what they mean. There's also a cap feature that the user can use if they really want to keep the log small, like if they really care about import times, that will sort of aggressively force the backlog size down towards some threshold. And there's a couple of tunables around that for more advanced users.
Yeah, as we worked with Paul before on this patch in a private repo, and as I've told before, I'm not a big fan of that mechanism of flush pressure, which increments, decrements on itself and has a state. So it's not a blocker for me. I'll let it pass, but yeah, as I've told before, I'd appreciate somebody else to review it and comment. If it's okay for people, I'll accept it, but I would personally done it differently. As I've
Yeah, I
told,
mean, if
but
yeah, it has a lot of properties that I think are good. But if somebody else has, you know, a suggestion for other ways to get similar behavior, I'm happy to take a look at it.
All right, I think we're at time for today. So thanks everybody. And our next meeting will be in March 25th at the usual later time of 1600 Eastern, or that's 1 p.m. Pacific. Thanks everyone.
Thanks, Alan.